Hi and welcome back to my channel, and this week's problem is a fun one, an interesting one. Now I have got this problem, or I know that a simpler version of this problem was on an assessment in China, and I know that because of this video right here. I'll link it down below and you can see that later on. That's a video from a very well known channel called Mind Your Decisions. Now this problem is like that problem, very similar, but it's more difficult. So we're going to have a look at how you would do this. And the top part means that A, B, C and D are elements of the positive whole numbers or positive integers. So we can only have whole numbers, they can't be zero, have to be positive. And we want to know that if A, B, C and D satisfy this stacked fraction being equal to 17 over 60, then what is the sum of A, B, C and D? Okay, now before I get into rearranging this and solving it, there's a few things that I'm going to use throughout my solution. So we're going to talk about those very quickly first. Now the first one is this, and that is that if we're adding a whole number to a fraction, we need to basically make that whole number, or that letter, into a fraction with the same denominator before we can add it. Now a in this case is the same as a over 1 as a fraction, and so if you multiply top and bottom by b, we will get ab over b, which then has the same denominator, which we can then add to get a single fraction, so ab plus 1 over b. And that is something which I'm going to use throughout this solution, and so I just wanted to put it up there just so that we're all clear, everybody watching is clear what I'm doing. Now the other thing that I will be using is this, and this is when we've got 1 over a fraction. So 1 over a over b, that is the same as b over a, and the reason that is because you can multiply top and bottom of the whole fraction by the denominator of your denominator, if that makes sense. So 1 over a over b, I can times top and bottom by b over b. That will cancel out the denominator in my denominator. I want to get rid of that, and then I'll end up with that denominator of my denominator on the numerator. So I end up with essentially that bottom fraction flipped. Okay, right, now the next thing is to start kind of rearranging this problem, and you want to start from the bottom with stacked fractions. So I wanted to, well I did, sort out this c plus 1 over d. So just like with my a plus 1 over b, I times the c by d over d, and I got cd over d, and then I added it, so I got cd plus 1 over d, a single fraction. Now from there, I've got 1 over cd plus 1 over d. So using my second rule that I've just explained, I can essentially flip that denominator of my denominator up to the top and make it a numerator. So I get d in this fraction over cd plus 1. Okay, so that's tidied up, we're getting there, but obviously as we go this is going to get more complicated. So now if we sort out and combine that b with that bottom fraction there, I need to multiply b top and bottom by cd plus 1. And what I am going to do is I am going to leave that factorised, because actually if I expand it, it's not going to help me. It's actually going to make things more complicated. Factorising things makes it easier to understand, because basically it tells you what it's made up of. Okay, now again, if we're going to tidy the page up very quickly first, just to make it a little bit easier to see. We've got space. So now we are going to simplify this again by sorting out that 1 over part at the bottom of our fraction. So we get this, and the denominator, again, the denominator of the denominator becomes your numerator. So we've got that cd plus 1 over b bracket cd plus 1 plus d. Okay, now we need to add the a in the denominator to that other fraction, and we need to multiply the a by that denominator, top and bottom, which is b bracket cd plus 1 plus d. So we get this, and it looks very messy, let's be honest, okay? But keep everything factorised, don't be tempted to expand it. And the final thing we need to do here is flip it, because we've got 1 over again. So we're going to get this. Okay, now again, we're going to tidy that up very quickly, bring that up here. And we don't need those rules anymore because we finished using them. Now, the next key bit for this is that the 17 over 60 is simplified. It's fully simplified because 17 is a prime number and it doesn't go into 60. So it will have no other factors, no common factors of 17 and 60 apart from 1. And our left-hand side of this equation that we've got is also fully simplified because I've kept everything fully factorised and there's no common factors for everything. Okay, I can't factorise anything out of D, and I've got a 1 in the denominator, so that's as simple as I can make it. Now, what that means is I get these two equations. The numerator must be equal to the numerator, denominator must be equal to the denominator, because they're both fully simplified. Okay, carrying on with that, and this is really one of the key bits, and that's realising that actually we can substitute here. So this left-hand equation I can plug in, and you will always be able to do that somewhere, somehow, because you've got that denominator in there, haven't you? It's part of that fraction because of the way we've added them together. Okay, so we plug that in. We're going to plug in basically 17. We're going to replace b bracket cd plus 1 plus d with 17. Okay, now I'm going to write that in the usual way and tidy that up. So 17a rather than a bracket 17. And I want to, at this point, just take away the 1 because I'll just make it easier, wouldn't it? So take away the 1 from both sides and I get 17a plus cd equals 59. Okay, now this is the point at which, you could be starting to struggle. You might be thinking, okay, well, I could just try things and see what works. Okay, now the key bit here is that multiples of 17. There are only so many, and we have to have positive whole numbers. And so if I just write these out, first of all, we've got 1, 2, 3, 4. Okay, and we've got 17, 34, 51, 68. Now, there's a couple that you might automatically think we can rule those out immediately, and you might be able to explain why. But I'm going to write down in a formal way, at least, why that is. Now, if we look back on the left-hand side, the left-hand equation, d must be a positive whole number. Okay, well now what that means is that b bracket cd plus 1 must be less than 17, because if we take away d from both sides, we're going to end up with something less than 17 because it's a positive whole number. It must be 1 or bigger. Okay, now b must be, again, a positive whole number. So if we divide 17 by b, we are going to get some number. Okay, so we're going to get, again, a number that's less than 17. CD plus 1 must be less than 17. We don't know what it's going to be because we don't know what b bracket CD plus 1 was, but we know it's got to be less than 17. Now, if we take away the 1, we get that CD is less than 16. Okay, now one more thing to add to that is because C and D are both positive, we get the other side of that inequality in that CD must be somewhere between 0 and 16. Has to be. Okay. Now, we can bring that over to the other side, this right-hand side equation. Okay, just tidy that up quickly. But if you bring that over to the other side, what we're going to get is that 17a must be bigger than 43. That's 59, take away our 16. Okay. And it must be less than 59 because CD must be bigger than 0. So we get that 17a must be somewhere in between those two numbers. Now, you might have been able to work that out before just through trial and error, essentially, or, that logic, that type of logic in your head. In that CD must be less than 17 because the whole left-hand side equation on your screen must be less than 17. Well, must be equal to 17, but if you take away D, less than, and so on. Okay. Now, what that means is that it rules out all the numbers. We end up with just one possible number, and that is this one. 17 times 3 is equal to 51. So 17a is equal to 51, and a is therefore equal to 3. So we substitute this in. We get 51 plus CD is equal to 59. We know 17a is 51, it has to be. Rearranging that, we're going to get CD is equal to 8. And what we can now do is plug that back into the other equation. So we plug that back in, and what we get is b brackets 8 plus 1 plus d. Now we can't substitute in for d because we don't know what d is yet. We could plug it in as 8 over c, but that probably is not going to help at the moment. So we're going to leave it like that. Simplify it. We get b brackets 9 plus d equals 17. and then let's write it properly. Okay, 9b plus d is 17. Now we're going to use the same logic here. Now we're not going to write the multiples of 9 down because actually there's only 2 to consider. 0 isn't 1, it's got to be positive. And so 1 times 9 is 9. Okay, so 9 plus something is 17, that would work. 9 times 2 is 18. That's already bigger than 17, and that makes d then impossible because d can't be negative. It would have to be minus 1, which isn't possible. Okay, so as b is a positive integer, we end up with b must be 1. Tidy that up again and substitute it in. 9 times 1 plus d is 17. 9 plus d must be 17. And so we get that d must be 8. Okay, we're pretty much there now. Tidy that up. Now we're going to go back to something from earlier. That's that CD is equal to 8. And if D is equal to 8, then of course C must be 1. Tidy that up, and we've got all of our numbers now. So we're going to get rid of everything from the screen, make it all really clear. We've got A is 3, B is 1, C is 1, D is 8. We're going to do a bit more substitution, plug it all in. 3 plus 1 plus 1 plus 8. And the final answer is 13. Okay? Now I think that's a really neat problem. It involves quite a lot of different skills, and there's probably multiple ways you can do this. And if you did find another way, then please drop it down in the comments below, and I'll be interested to read and see your solutions as other people would as well. Okay, I hope you enjoyed that video, and I will see you next week for another problem. Till then, see ya. Bye-bye.